In this video, we'll take a closer look at controllers in ASP.NET Core. At this point, we've seen some controllers already. So what exactly makes a controller a controller? Well, it's actually quite simple. Any class that has a name that ends in controller and/or inherit from the controller base or controller class will be treated as a controller by the framework. We usually place the controller classes in the controllers folder, but just like other C# classes, they could be in other folders if we want. Inside the controller class is the action methods that actually handle requests. In this video, we'll focus on three things related to action methods: how to get input data from requests, how to pass data to views, and the result of an action, or in other words, what an action method returns. We'll start with the action result. So what does an action method return? We know that ultimately a web application returns a HTTP response to the client, but action method usually doesn't generate a HTTP response directly. Most of the time, an action method will return a view, actually part of a view, and the framework will combine the view with a layout page to produce a final response. But that's not all an action method can return. If it's a request to download a file, it could return a file. If the request doesn't have the necessary information, it could return an error, or it could return an object for a web API, or simply redirect to another URL. In fact, an action method could return more than one type of result, depending on the request. For example, if the request is from an authorized user, the method returns a view, but otherwise it redirects to an access denied page. This is why the return type we use most often is iActionResult. It's actually an interface for all the possible return values of an action method. If we take a look at the API documentation, we can see all kinds of results implementing this interface. So now we know the action method usually returns some kind of iAction result. But what exactly are we returning here? What exactly is this view? For that, we need to look at two superclasses for controllers: controller base and controller. Controller inherits from controller base. User-created MVC controller classes usually inherit from controller, while user-created web API controllers usually inherit directly from controller base. Let's take a quick look at controller base. This class basically provides two things. The properties of the class give us ways to access various data related to a request. And this class also has a bunch of helper methods for creating various action results. Most of these helper methods are useful for creating web APIs. For MVC applications, one type of helper methods we'll use quite often is the redirect helper method. For example, if we want to redirect the client to another URL, the action method will say something like return redirect and then a URL. And this redirect method will take the URL and create a redirect action result. Now let's take a look at the controller class. This class inherits from controller base, so it gets everything controller base provides. In addition, it adds support for views, and this is why MVC controllers usually inherit from this class. Here are the things the controller class adds on top of the controller base class. I highlighted the three things that we'll use the most often. We already saw the use of the view method. It's a helper method for producing a view result. The view data and the Buildback properties are for passing additional data to a view. Let's take a look at the example we did last time. Here, we can see that, actually, let's run this code first. So we have a controller class here. This action method will get all the employees from the database and pass them to a view. And in the view, we display the employees in a table. So this is what it looks like. Now, in this example, we can see that ASP.NET only allows one model object for a particular view. And this model object is passed to the view as an argument to the view helper method. And inside the view, it has to be declared using the @model syntax, and it can be used in the view code using the special variable called model with a capital M. The problem is that what if we need to pass more than one object to the view? Well, then we'll use either view data or Buildback. View data is a dictionary with string keys and object values. We can put anything into view data in controller and then use it in the view. For example, here we can put some additional object and pass some additional object to the view. So let's say we'll say view data, and let's give it a key. Doesn't really matter. Let's say we'll say name, and the value for that we'll say CS4540. And here in the view, if we want to use that data, we can say something like view data and simply reference it here. So passing some data as an entry inside view data, give it a name, and then we can reference that in the view using that entry, using that key. If we run this, we see CS4540 here. Because view data is a dictionary, we can put as many objects in it as we want. So there's no limit on how many objects we can pass to a view. The only inconvenience is that because the value type of the dictionary is object, sometimes we need to cast the object to its real type before we can use it in the view. For example, something shown here like this. If you don't like casting, ASP.NET Core provides an alternative called Buildback. Buildback is something called an expandable object, which is an object with dynamic properties whose types are determined at runtime. If you are familiar with JavaScript, you can think of expandable objects in C# like objects in JavaScript. Its properties can be dynamically added, and the types of the properties are determined by the language runtime. Buildback serves the same purpose as ViewData with slightly different syntax. So for ViewData, because it's a dictionary, if we want to add something to it, we use the dictionary indexer syntax. But if it's ViewBack, it's simply a dynamic property, meaning that we use the property syntax, and this property will be dynamically added to this ViewBack expandable object. And similarly, in the view, we'll use the property syntax instead of the indexer syntax. We'll say ViewBack name here. And let's change this to something else just to make sure it's indeed running the latest code. We'll change this to John. And now it says John. Again, it's just slightly different syntax. Instead of the indexer syntax, it uses a property syntax when we use ViewBack. Here's a quick summary and comparison of model, specifically view model, view data, and ViewBack. If we only need to pass one object to view, we should definitely use model because the type can be determined at compilation time because we declare it using @model, and because of that, we get additional support from IDE like code suggestion and completion, and it's also used by form tag helpers. We'll talk about tag helpers next week when we discuss wizard views. ViewData and ViewBack are basically the same, with ViewBack being slightly more convenient as it doesn't require casting, as a cost of a little bit more overhead to determine the property types at runtime. Which one to use is really just personal preference. It doesn't matter much either way. Okay, now that we understand the action result and how to pass data to views, let's look at how to get information from requests. We'll start with this example where we add an operation to display the details of an employee. The URL used will be employees/details/ the value of the ID or the ID of the employee. As we know from routing, we'll need to implement an action method called details in the employees controller for this. So we'll continue to use the example we developed last time. It's basically the same code as shown in the last video, except that I added a couple of more methods in employee service. So last time it's just one method to get all the employees, and now I added two more methods. One to get one employee giving an ID, and the other one to add a new employee to the database. So the implementation is pretty simple. Here we just do a link query to get the employee object with the given ID. Now here is the use of the include method. In the last video, I tried to show it with this one, but turns out that this one actually doesn't need it. But this time, if we do not have this include method, this query will only load supervisor ID. But if we also ask it to load the whole supervisor object using this include, basically saying include also the full supervisor project object, will get also the supervisor information. So we'll test the, we'll play with the sample code. You can try include this method or not include it and see the difference. And the third method basically adds a new employee object and save it to the database. So these two methods are newly added, nothing else. There's also two methods for the mock implementation, which is not really relevant here, but otherwise it's the same code as last time. And now let's implement this operation, employee details. So we know that the first thing we do is to add another method here. The return value will be action result, as we discussed earlier. And the method name needs to match the second segment of the URL, so we'll call it details. And then we'll say integer ID. And the implementation will be quite simple. We will call employee service and we'll say get employee ID value. And this will return an employee object and we'll pass that employee object to the view. If you remember, the view should be under the employees folder under views, employees matching the controller name, and then the view name should match the action method name. So this one will be called details. And we're going to declare the model type, which is employee. And then the rest is basically up to us. So I'm going to, again, put it in a table. And each row of the table will show certain information about the employee. So this one will be the ID. And then we'll have name. And let's just say we have supervisor, which is the supervisor ID. Just to keep the view simple, so we don't need to check for supervisor, whether supervisor is null or not, and those type of things. And so if we run the code, these are the employees. If I say details 1, it shows John. And if I say details 2, it shows Jane, employee ID 1, and so on. So it works. So this example is pretty simple, but it shows a very important concept, binding. Binding is a process of mapping the data in a request to the parameters of an action method. Notice that here, our action method has a int parameter ID. We're not really doing anything special, and somehow we get this ID from the URL, and that's the binding process in effect. So what this process does is it takes this value 1 and it passes it as the argument to the ID parameter of the details method. In general, data may come from many different places in a request. For example, in this example, the data comes from the so-called route parameters. These are the parameters defined in our routing pattern, and it tells the framework that this value, the third segment of the URL, should be passed as the ID parameter to the action method. So as you can imagine, we could have additional route parameters defined in a routing pattern. Later on in a video about routing, we'll look into this a little bit more. Then we could also use query parameters in this form. This is what we did the most often in classes like CS3220. When we talk about request parameters in CS3220, is mainly query parameters. We have URL, then question mark, then parameter value name, parameter name and value pairs separated by this and symbol. Now, in addition to this, we could also have data inside the request body in the form of posted form fields or uploaded files or some objects in JSON or XML format. And we could also get information from request headers if we want. So let's quickly do an example using query parameters, since sometimes you may want to pass more than one parameters to a controller, to an action method, and if route parameters are not enough, you can add as many query parameters as you want. For example, let's say we expect some additional query parameters here. Let's say we expect a query parameter A and B, and then we can simply put them there, and then we'll put them in, let's say, Buildback. And inside the view, you can say A is Buildback A, and B is Buildback.B. And if I do details 1, we get John. Nothing for A and B. If we say question mark, A is 10 and B is 20. It shows A is 10 and B is 20, meaning that we get both query parameters in our action method. So as you can see, it's actually pretty simple. All we need to do is just put them as parameters of the action method, and we get them. The reason it's so simple is because in ASP.NET Core, route parameters, query parameters, and request body are used as the so-called binding sources by default, meaning that we don't need to do any additional configuration, and the framework will automatically try to do binding from all these sources. Now, if we do want to specify exactly which binding source we want to use, we can use these attributes. For example, if we want, we could say this parameter has to be from query, for example. And or this parameter has to come from form or body or header and so on. So this allows us to specify exactly which binding source a certain parameter should come from. Okay, now let's do another example. In this example, will we'll implement this operation that adds a new employee to the database. And using this example, I want to show three additional things. Routing based on HTTP request methods, something called binding model, and also the use of the redirect to action method. Okay, so first of all, let me look at my database and see what's currently in the database. So go to database 31, table. If we look at the table now, we have 5 employees: John, Jane, Tom, Bob, and Jack. Okay, let's say we want to add a new one, and the URL will use is this one. We'll use employees add. So that means we will need to add another method here called add. Now, if you remember, add a new employee requires that we display a form, and this form will show some input boxes like the employee's name and so on. And then there's also need to be another action that handles the form submission. So in other words, although this is one operation, there are actually two actions involved. One action is display form, and another action is process form submission. Now, if you remember what you did in CS3220, when we do this using servlet, display form is handled by the doGet method, and processing the form is handled by the doPost method. So in ASP.NET Core, we don't have doGet method and doPost method. How do we say I want to use this method to handle GET request, and I want to use another method to handle POST request? Well, we can use HT method attributes. So in other words, we can add an attribute here, and this attribute basically says if there's a request comes to the URL employees/add, and if it's a GET request, please use this method to handle it. And in this case, we're simply going to return a view. And to create that view, we can go to this view folder, and again, notice that view name should match the action method name. So we're going to create a view, and this view is going to be called add. And this view will show a form. So let's just do a ugly form here. And employee has an ID, which is going to be automatically generated. We want to provide the employee name and date hired. We'll skip supervisor ID for now. Later on, when we build more on top of this example, we'll see how to add supervisor to the mix. But for now, let's just create a new employee without supervisor, just giving separate employee name and date hired. So name should be input box, and the name of the field, we are going to call it capital name. We'll see why in a moment. And then date hired type is, so it's going to be a date, and it's going to be called date hired. And then let's do a submit button. And we'll say method is post. So the get a get request will show this form, and a post request will do the form submission thing. So let's run this, and let's make sure that we can see the form first. Is it running? Okay, so it's running. And if we go to employees add, we did get this to field, this form, so looks good. Now we need to implement the post method. So the post method can have the same name. We'll use the same method name, add, and this time we'll add the post attribute to it, basically saying that a post request to this URL will be handled by this method. Now the question is, what do we put in here? Now, if we look at the form, we see that it has two form fields called name and date hired. So immediately we could do something like this. So this would in fact work. We get those two form submission form fields as the as two parameters. One is called name, one is called date hired, and it's basically the same thing like this. But here we want to do a little bit better than this. The reason being that this is a simple form, only having two fields. But in practice, a form can be quite complex. It's not uncommon to see a form with 20, 30 different fields. And you certainly do not want to create a method with 20, 30 different parameters. That's too much, and not only tedious, but very, very error prone, very easy to make mistakes. Instead, we are going to rely on something called binding model. So instead of spread out all the different fields, we are going to put an employee object here. What will happen is that the framework will try to put the name into the name property of this object, and it will try to put the date hired into the date hired property of this object. So in other words, we get all those form fields together inside one object, which is much easier to specify and much easier to handle. And this object is known as a binding model, meaning that it's a model object used for binding. And remember, binding is to map data in HTTP request to the parameters of action method. Now, that brings up this issue about models in MVC. So far, including in CS3220, when we talk about models, we typically refer to, we typically mean so-called domain models, meaning data models, or the model classes represent data in your application, data related to saving data, retrieving data from database, and so on. But in practice, it's actually only one type of model, known as data model or domain model. There are two additional types of models which are also very commonly used. One is this binding model. Basically, model classes used to bind requests to the action parameters. And in here, we are actually using employee as a binding model. Now, another type of model is a view model, meaning that this type of model is used to pass data from controller to view and for display purpose. Now, oftentimes we actually use the same model class for domain and for view and for binding. In fact, this is exactly what we're doing here. We only have one model class, employee. We are using it as a data model or domain model, and we also use it as view model. And here we are using the same class as binding model. And sometimes this is fine and it's actually quite convenient. But sometimes it may be necessary to create separate classes, for example, to prevent the so-called overposting attack. We are not going to go into details about the so-called overposting attack, but basically it means the user will post additional data to your binding model so that they will specify things that they should not specify. If you are interested, check out the linked article. But the main takeaway from this is that A, there are different types of models in MVC, not just data models, and B, although in our example, we use the same class for different types of models, but oftentimes you may need to create additional classes for binding models, for view models, and so on. Okay, so now suppose everything works correctly. Before we do that, let's also quickly mention that the ASP.NET Core Framework binding actually is quite powerful. Not only it binds simple data like integers, strings, and so on. Not only it binds to objects with properties, it can also bind collections. For example, if you have two parameters, both have the parameter name numbers, they can be bind to a list, and you can even bind them to specific index at the list by manipulating the parameter name, by adding the index to the parameter name, and you can even bind dictionaries, again, by specifying certain parameter names. So this may be useful for later, but just so you know it can do this. Now coming back to our example, suppose everything works correctly. The user submits the form data goes into this object. Then all we need to do is to add employee to add this to the database. And then what happens after that? Typically, what happens after we add another employee is to redirect the user back to the employee list. So how do we do that? ASP.NET Core provides a number of helper methods for redirect. You can check out the controller-based the API documentation, you'll see a whole bunch of redirect related helper methods here. The most commonly used one is probably this one called redirect to action, and this one will redirect the user to a URL that matches a certain action method. So here we can actually simply say return redirect to action, and we simply redirect the user to the index action, which is this one, and the framework will automatically generate the proper URL and send the user to there. So let's try this. And right now we have John, Jen, Tom, and Bob, and Jack. Let's add one more. Let's say we add Sue, and let's say Sue is hired today, and add. So we can see that Sue is here, and if we look at the database, we can see Sue is added here. Now, first of all, I like you to kind of appreciate the simplicity of this code, compare it to, for example, what we did in CS3220. And this is a good example of showing the power and the convenience of using a framework. Just with a couple of simple lines of code, we take the user input and save it to database, and nice and simple. And second, of course, is once again the so-called the concept of binding and binding model. Okay, so this is the end of this video. There's no readings this time because what we discuss in this video kind of scattered around in several chapters of the ASP.NET Core in Action book. So there's no actual reading this time. Thanks, and see you in the next video.